Alright guys, let's solve practice problem number 9. A 25 kilogram mass is hanging by 3 cords as shown. Find the tension in each of the 3 cords in newtons. Please note this is 25 kilograms here, but it reads 5 kilograms here. This should be 25. My pen's running out. 25 kilograms. Sorry about that. That was an oversight. Okay, so we need to get T1, T2, T3. Let's start with the easiest, T3. T3 is a tension that arises due just to the weight of the object. Without T3, the object would fall to the floor. And without the weight of the object, there would be no tension. So let's see. I'm going to use G as 10 meters per second squared. So the weight of the object, T3 minus the weight would equal 0. T3 minus the weight equals 0 according to our equation for the resultant force, which means that T3 equals the weight. T3 equals 25 times 10, which is 250 newtons, and that's T3. So that's super easy. Now T1 and T2, not so easy. And what makes this problem tricky is the fact that these angles aren't equal. These two tensions, T1, T2, you can break them into their vertical and horizontal components. Let's go ahead and do that. They have components of tension that are in the vertical direction. They actually are equal to tension 3. They give rise to T3. I'll label this one TY1 and this one is TY2. So if these angles were the same, hey, I could say that TY1 plus TY2 equals 250, and I could say that, okay, TY1 equals TY2, so that would be 2TY equals 250 newtons, and my vertical components would be each 250 divided by 2, and then I'd have an angle and a known side for my vector triangles, and it would be great. It would be easy, but I don't have that. I have 2 different angles, so if you don't believe me, maybe you can try this at home. If you take 2 strings, or even 1 string, and you hang like a picture from that 1 string, but you have one side longer than the other, you'll feel that there's different tension on each side. If the angle isn't the same, there will not be even tension from T2 and T1. The tension's not even on both sides, and you'll notice that because a picture frame or a picture might hang to one side. It might be a little lopsided rather than perfectly even. Okay, so I'm going to write an equation for the net force in the y direction. I know that T3 goes up, but there's also still this weight. I'm translating this vector up here. So the weight is 250. I'm going to say Ty1 plus Ty2 equals 250 newtons. These vectors point up and they oppose the weight of the object, which is also transferred through T3. Okay. Alright, that doesn't do me any good. I have 2 unknowns and 1 equation. If you have 2 unknowns, you need 2 equations. 3 unknowns, you need 3 equations. The number of unknowns you have in a problem equals the number of equations you need to solve that problem. Let's look at another aspect. Let's look at their horizontal components. So T1 and T2 both have these horizontal components of their tensions. The object isn't swaying from side to side. The object isn't being pulled in a horizontal direction, which means that these 2 tensions have equal and opposite horizontal vector components. That is to say that Tx1, and I'll choose the left to be negative, negative Tx1 plus Tx2 equals 0 newtons. The object doesn't exhibit a horizontal force at all. So instead, the only horizontal components of force are what arises naturally due to the tensions. They have angles, and so part of their vectors are resolved in a horizontal direction, but they're equal and opposite to each other. The object isn't swaying. So I can say that Tx2 equals Tx1 if I just rewrite this equation. Alright, so I have two equations, but now it looks like I have four unknowns. The horizontal component of Tx1, horizontal component of tension 2, vertical component of T1, and vertical component of T2. Oh my. Well, I actually only have two unknowns because I can rewrite these horizontal and vertical components of the vectors in terms of T1, T2, and some trig functions. So let's start, because I have the pink pen still, I'm going to start by rewriting my horizontal tensions. So Tx2, you can write that as T2 times, this is an adjacent side to the angle, this T2 is like a hypotenuse, so this is T2 cosine of 50 degrees equals T1 times cosine of 40 degrees. And then over here, I can do the same thing using trig. I can say that Ty1 is T1 times sine of 40 degrees plus T2 sine of 50 degrees equals 250 newtons. So now I have two equations, two unknowns. My two unknowns are T1 and T2, and I can either set up a matrix and use Gaussian elimination to solve, or I can do substitution elimination. So I am going to solve for T1 on this side and plug it into this equation over here. So T1 equals T2 times cosine of 50 degrees divided by cosine of 40 degrees. And now this that I have right here, I'm going to plug in for T1 right here. So if you feel confident with this, go ahead and do it and solve for T2 and then solve for T1. But if you're not confident, just follow along with me. I'm going to replace T1 with everything in here, and I'll write it down in the space below. So T1 is being subbed out for this. T2 cosine of 50 degrees divided by cosine 40 degrees. This is what's in that parentheses. Times, I can't neglect this part right here, times sine 40 plus T2 sine of 50 degrees equals 250 newtons. So what I'm going to do is I will factor out T2. I have a T2 here and a T2 here, and I'll factor it out up here. So I'm going to factor out my T2. Let me box out some space. T2 I'm factoring out times cosine of 50 degrees over cosine of 40 degrees. Okay, let me open a bracket here. Times sine 40 degrees plus sine of 50 degrees equals 250. So T2 was replaced. T2 was factored out. So all this T2 could be distributed to this term and to the sine 50 term, and you would have the same thing. Sine 40 over cosine 40 looks a lot like tangent. So I'm going to rewrite this one more time. T2 times cosine of 50 degrees times tangent of 40 degrees plus sine of 50 degrees equals 250. So now I can quickly solve for T2. I'll divide by cosine 50 times tan 40 plus sine 50 and I'll divide this on both sides. So T2 becomes 250 newtons divided by this cosine 50 tangent 40 plus sine 50. Be sure to use parentheses, especially in the denominator, and I get T2 equals, and I'll plug this in, 250 divided by, open a parentheses, cosine 40, cosine 50 times tangent 40 plus sine 50. And I get a tension 2 of 191.5 newtons in T2. And now to get T1, I can take this 191.5 newtons and plug it into here. So T1 equals 191.5 times cosine 50 divided by cosine 40. Let's do it. That times cosine 50 divided by cosine 40. And I get T1 equals 160.7. Or I'll just round, 160.7 newtons. And you can round down to 2 sig figs. But here we go, T1, T2. If you found this challenging, well, this is a college level question. For SL, you will not be asked to this level, and I don't think HL you would be asked to this level of difficulty. You might be given angles that are equal, which would greatly simplify the problem, but I want you to push yourselves and to experience a college level question like this. So I hope you found this video helpful, and hopefully it'll be helpful to you in university physics. Thanks for watching.